All right, so basically, yeah, we're going to start with the first topic you guys want me to cover was the models of stress. So when we're looking at the models of stress, we're basically talking about two main models, and we define them as biological and psychological. So the biological model relating to stress is called the gas model. Okay, and the gas model is basically this idea that when we encounter a stressor or something like a threat in the environment, something that's stressful, it could be you losing a job, it could be you finding out you failed a SAC, or it could be more of a physical threat, like you walking in the street and there's a bear that comes out of nowhere. Okay, generally, whatever stressor we're talking about, or whatever threat we're talking about, we can use the gas model to explain that threat. So the gas model is a three-stage process, and this process is a biological process. So it's a three-stage biological process consisting of three main stages. The first one is called alarm reaction, or simply alarm. Alarm is basically consisted of two sub-stages or mini stages within that. So alarm is consisted of, first of all, shock and then counter shock. So shock is when you first encounter a stressor, your body goes into shock, which is basically the sympathetic nervous system, which is basically preparing for the sympathetic nervous system to take charge. But before the sympathetic system, nervous system takes charge, the body goes into shock, which means the blood pressure goes down, your body temperature goes down, you lose muscle tone. So the shock stage is basically representing that freeze component. Remember how we said that whenever we encounter a stressor, we can either fight it, flight, or freeze, so fight, flight, or freeze model. The shock component of the gas model looks at the freeze component. The counter shock, on the other hand, is when your fight and flight sections come into play. This is when your body's like, okay, I can't stay frozen forever. I've got to find out how I'm going to deal with this. So then the counter shock stage within alarm reaction is when we've got, people basically having their fight flight response activated. Fight flight response being activated means your sympathetic nervous system is also being activated. Okay, so all of those conditions, those effects that we talked about, like increased heart rate, increased blood glucose going to the muscles, all that stuff starts happening. So by the end of the alarm reaction stage, a person would have experienced the freeze reaction, the fight reaction, and the flight reaction almost as a whole reaction there. Okay, so the alarm reaction stage is the first stage, and because it's the first stage, it represents the immediate initial reaction that you've got to the stressor that you've encountered. The next stage is the resistance stage. Obviously, if you've already resolved the issue, like if, for example, your teacher says, Fatima, you have failed the SAC, okay, but then you go through this alarm reaction, but then the next day they come and it's like, oh, sorry, Fatima, I've read the result wrong. You actually didn't fail. You got 70%. Then you don't actually go to the resistance stage because the stressor has disappeared. The stressor is no longer there. Obviously, if the stressor still is there and you have failed the SAC and you are now worrying about it, you go into the second stage. And the second stage of the gas model is called the resistance stage. Resistance is when you're trying to resist the stressor. In other words, you're trying to do everything in your power to fight the stressor, to cope with the stressor, to adapt to it. So in order to do this, your body needs to obviously put a lot of energy and a lot of its resources into fighting the stressor, into fighting the effects of increased cortisol and all those things. So what happens is all the unnecessary bodily functions like digestion, growth, menstruation, all of these are processes that are not required for survival. Okay, obviously your heart beating, your brain working, those are important, but these are what we call as unnecessary bodily functions that do take up energy. So if we can take away the energy used for these processes and use them towards fighting the stressor or towards dealing with the stressor, that's what the resistance stage is trying to tell us. In the resistance stage, also our main stress hormones are released. So we've got cortisol and we've got adrenaline being released. Now, obviously, because cortisol is released in the resistance stage, your immune system starts to get suppressed within the resistance stage as well. And you'll notice that whenever you do like scenario-based questions and things when it comes to gas model, you'll notice the person starting to get sick. Okay, and that reason that they're starting to get sick is that the cortisol has started to kick in and has started to put a lot of pressure on the immune system. Now, if you still haven't dealt with the stressor by this stage, then you move into the third stage, which is the exhaustion stage. The exhaustion stage suggests that the body has tried its utmost efforts to get rid of the stressor or to cope with the stressor, but it has been successful. It has basically failed in its attempts to do that. So basically, what we're trying to say here is that the body has used up or depleted all of its resources and it can't cope anymore. Okay, and in the exhaustion stage, this is when the person starts to develop more serious conditions like heart disease, anxiety, depression, nightmares. All of these things are more serious health issues compared to just getting a cold or a flu, which might be something we see in the second stage. Okay, so obviously exhaustion doesn't just cause disease straight away. It happens over maybe a period of years. Okay, this is more for people who have stresses that they can't deal with straight away. So people going through maybe domestic violence, okay, people going through relationship issues that continue for years and years and cause them stress nonstop. Okay, so obviously that is the GAS model. Any questions about the GAS model? No, all good. All right, cool. Okay, if a question says that if person is starting to get sick, is it resistance? Yeah, if it says they're starting to get sick and the sick is like they're developing like cold symptoms or flu symptoms, then that would most likely be resistance. However, VICA are quite open-ended about this. And the reason is that some textbooks actually say that sickness begins in the exhaustion stage. Some textbooks say that it actually begins in resistance. So they accept both responses. Even with reference to cortisol, most textbooks say that cortisol is released in the resistance stage, but some of the textbooks actually say that it's released in exhaustion. For that reason, VICA actually accept both answers for a question like that. Okay, because obviously different schools use different textbooks and it's not fair that one school is disadvantaged compared to another. So there is a bit of controversy around that area, but again, both of those answers are accepted. Cool, so that's the GAS model. So let's move on to the next model of stress, which is our psychological model. And again, if you have any topics that you start to think about that you need extra help with, just put them in the chat box and we'll cover them as we go ahead. Okay, so yep, the strengths and limitations. So like I said, just know 2 strengths and 2 limitations. I think you guys were pretty good with this. Remembering that whenever we're talking about biological models or biological theories relating to stress, the only one that we're talking about is the GAS model. Whenever we're talking about psychological models related to stress, the only one we're talking about is the transactional model. So be very, very clear in your notes and when you're studying that this is the psychological model and the GAS model is the biological one. Because if you get a question that says outline the biological concepts relating to stress, you are going to have to talk about the GAS model as well as the role of cortisol and all that stuff within that kind of a question. And in the past, a lot of students in VICA exams, especially in the 2018 exam, when they were asked to talk about biological models of stress, they didn't understand what that meant. They started just talking about cortisol in general. They didn't even bring up the GAS model at all. So just be really careful with this terminology. So when we're looking at the psychological model of stress, basically what we're looking at is the transactional model of stress and coping. So when we're looking at the transactional model of stress and coping, it's basically suggesting the importance of interpreting stresses. So basically it looks at appraisals. So we're looking at primary appraisals and secondary appraisals. So in primary appraisals, that's when we initially try to interpret or appraise the stressor. In secondary appraisals, that's when we decide how we're going to cope with the stressor. So when we're looking at, hold on, let me go to the next slide. When we're looking at a stressor, you know, 2 people could be going through the same stressor, but the way that they're appraising or interpreting that or evaluating that stressor is going to be different. So when we're looking at these 2 stressors, they're the same stressor, but the way that these 2 boys have interpreted it is different. One person thinks it's very stressful, the other person doesn't really care much. So when we're looking at the process of how transactional model works, when you first encounter a stressor, let's say that it's a stressor like, the VICA exams have been pushed forward by, 1 week. So you're going to have them 1 week earlier than expected. Okay. Some people will find that very stressful because they're not well prepared yet. They haven't even started their revision. Okay. They're very stressed by that. Some people will find that irrelevant. If you're a year 10 student and you've been told this information through an announcement, you're in year 10, you don't even do VCE. It's not relevant to you. So you're going to choose that appraisal. Benign positive is either it's harmless to you or it's positive. Maybe in the original timetable that VICA had put out, you actually had 2 exams on the same day. But because they've pushed the exam timetable a little bit forward, now that leads to your 2 exams actually being now on separate days rather than clashing on one day. So for you, that's a good thing. You're happy. Okay, and that's positive. Benign means that it doesn't harm you because you've already revised everything. You've done enough trial exams. You're confident. You're happy that you're happy to do it next week. It doesn't really affect you. So that's basically the primary appraisal. Now, if you choose the irrelevant primary appraisal, for example, if you're a year 10 student, you're not doing VCE yet, or if you choose the benign positive, which means you're already prepared or there's some advantage in you for the exams being moved forward, then obviously you're not going to move on to the next 2 stages. Yeah, it's only if we choose stressful that we then look at the further appraisals there. And stressful appraisal means that we can look at further appraisals like either harm loss. So we're looking at what damage has already been done. We can choose the threat appraisal, which is what harm could happen in the future. And challenge is how can you grow? So challenge is looking on the bright side. It's the more positive appraisal there. So obviously, if we're looking at our example here, harm loss would be what damage has already been done. Well, if this VCAR exams are being moved forward 1 week earlier than usual, the damage has already been done because I've already lost time for revision. I've already wasted enough time. And now I have 1 less week to study. Threat, what harm could happen? Well, my ATAR could get affected because the exams are moving forward and, I'm not able to obviously have enough time to study. I might not be able to do as well on the exam. Challenge is a more positive spin on things, obviously. So you could say, oh, you know what, even though this is difficult, everyone's going through the same thing. It's not like it's only targeted to me. All VCE students would experience this. And so maybe this is an opportunity to see how much I can actually get done within the time that I have, or how much potential I have to actually overcome this. The secondary appraisal is obviously what we call as coping. So secondary appraisal means how the person is going to cope with the stress. Now remember, secondary always comes after primary. So secondary appraisals can only happen once the primary appraisals have been accomplished in the first place. So secondary appraisal is you've dealt with the stressor, you've decided what it is in terms of the primary appraisal. Now you're deciding, how am I going to cope with this stressor? How am I going to control or manage this stressor? So problem-focused coping is obviously dealing with the root source of the stressor or the cause. So that could be you actually studying, rewatching all the Edrolo recordings, rewatching all the Zoom recordings, all that stuff, asking your teacher for help. Emotion-focused coping is dealing with your emotions about the stressor. So emotion-focused coping might be complaining about this issue with other people, talking to your friend, talking to your parents, talking to your siblings, trying to deal with your emotions. It doesn't really address the root cause of the issue. It doesn't really address the problem, but it does address your emotions. And a lot of people who use emotion-focused coping, once their emotions are under control, they find that they can then move on to using problem-focused coping because now they've got a clearer mind and they're not affected by their emotions as much. So again, you could be using both coping strategies or you could use one. And in a scenario, you could get a person using both. So you have to be able to pick that out. Alrighty, so just looking at I've already talked about what those copings are. So I'll just go through the strengths and limitations of transactional model, and then I'll go back and go through the strengths and limitations of the GAS model as well. So obviously strengths and limitations of transactional model, you can choose any 2 strengths and any 2 limitations. Obviously, the good thing about transactional model, unlike the GAS model, in the GAS model, I think they used rats as participants because that was an animal study. But the transactional model uses humans, which is obviously going to be easier for us to generalize the results. The transactional model also looks at the role of the environment versus the individual, whereas the GAS model doesn't really focus on the role of the environment at all. It just focuses on the role of the person. Okay. Unlike the GAS model, the transactional model focuses on psychological determinants. Determinants is another word for factors. It deals with this idea that people deal with stresses differently. It's not just about biological processes, but it's also about the way we think, the way we feel, the way that we behave and interpret and evaluate situations. Reappraisal. So obviously the transactional model doesn't just say that, oh, once you've made your primary appraisal, it's set in stone. It says that people can go back and change their primary appraisal. What you initially viewed as being stressful, after thinking about it for a while, you might actually be like, you know what, that's not actually stressful. It's more benign positive, or it's actually not even relevant to me. So again, you can actually go back and change your appraisal. And so that suggests that the transactional model is quite flexible. And obviously the transactional model is really good because it talks about coping. And we know coping is something that's not talked about in the GAS model. The GAS model just talks about all the diseases you're going to get from your stress, but it doesn't actually talk about how you can deal with those, how you can deal with the stress or how you can reduce your cortisol. some of the disadvantages of transactional model compared to gas model is that the gas model obviously is very scientific in nature. It's very physiological and biological. It's easy for us to test that experimentally. The transactional model, because it's dependent on what people think and people's individual interpretations of a stress or how they think or feel, it's more subjective. So it's very difficult for us to test the transactional model experimentally and objectively. Also, sometimes primary and secondary appraisals, although we follow the flowchart model where we say primary appraisals happen first, secondary appraisals happen afterwards, it doesn't always happen that way in real life, in a practical situation. So sometimes even before deciding that something is stressful, someone's already thinking about, okay, how am I going to deal with this now? How am I going to cope with it? Without even fully assessing the entire situation. Also, sometimes the transactional model suggests that in order for us to have a stress response, we have to appraise something as being stressful, but that's not necessarily the case. You might think that something is irrelevant to you, but then you realize that somehow you are implicated in that situation. So for example, a year 10 student who's not yet doing a 3 and 4 subject, but who's doing a unit 1 and 2 might be affected by some change that VICA has made to exams in some indirect way. And obviously, it's kind of like the opposite now. So the transactional model focuses a lot on psychological factors, but doesn't focus a lot on the biological factors or biological elements of stress, which is what the gas model looks at. And obviously it doesn't take into consideration cultural factors and social factors. So how a person from, Nigeria might interpret a specific stressor compared to a person from Australia. So something like early marriage in a remote village in Nigeria might be seen as a normal rite of passage or a normal part of life, but for a 16-year-old girl growing up in Australia, that might not be something that's, something that's normal for them. So they might be more likely to appraise that as being stressful because it's not a normal part of the culture or society here. So that's basically looking at the strengths and limitations of the transactional model and making some comparisons there to gas model. So any questions about the transactional model and the gas model? No? Okay. Oh, whoops, sorry, I didn't see these 2 questions. Okay, there's a question here about phobias. Okay, we will look at that one when we start the chapter 13 topic. So I will definitely get back to that one. And then a general question, do you have to get the name right, like the spelling? Yes, for the most part you do. It really depends. Like if your spelling is so bad that it suddenly resembles another word, like if your spelling of glutamate looks more like GABA, then obviously you would lose marks for that. But for the most part, they don't care too much about spelling. Just make sure that it's not so atrocious that it's hard to even make out what you're trying to say. That's about it. Okay, so what was the next topic now? Let me look at, okay, another question. What type of questions can we get for context-specific effectiveness and coping flexibility? That's a good thing. And now that we're still on the chapter 3 PowerPoint, when we're looking at context-specific effectiveness and coping flexibility, there's a lot of questions in past exams talking about the relationship between the two. Okay, the general relationship between the two is that when you've got better coping flexibility, you're more likely to choose coping strategies or ways of dealing with stress that are appropriate to your context. So what that means is that if you've got a more open mind and you're not so stubborn and you're not so a person that gives up as soon as something doesn't work, you're going to be more likely to continue to find a high context-specific effectiveness strategy. And that's basically the relationship between the two, that they work together in that sense. So if you've got a high coping flexibility, you're going to deal with stressful situations better, and you're going to have that experience and knowledge of how to choose a suitable method for dealing with the stress, which is context-specific effectiveness. So in other words, people with high coping flexibility have better context-specific effectiveness skills to choose methods that are high in context-specific effectiveness. Okay, and vice versa. So if you've got low coping flexibility, you're more likely to choose methods that are low in context-specific effectiveness. So that's basically the relationship between the two. And this is actually a really confusing part of stress. So make sure that you understand the main difference between the two. Okay, coping flexibility is about looking at the different stressful situations you're in and changing or adjusting your coping methods accordingly. If plan A doesn't work, you go to plan B. If plan B doesn't work, you go to plan C, whatever. That's basically how coping flexibility works. It's basically being flexible and open-minded about your coping strategies. Context-specific effectiveness is how appropriate are you being in terms of how appropriate is the method or strategy that you are thinking of for the actual stressor you're dealing with. So if you've got an upcoming debate, obviously preparing your speech, practicing in front of the mirror, writing on cue cards, those would all be examples of strategies that are high in context-specific effectiveness because they deal directly with the stressful situation, which is the upcoming debate. Okay, so that's basically the main definitions for those two concepts. Okay, so let me just go back up and see what our next topic to cover was. So we were going to go through the main elements. Yep, so we'll go through the elements of classical conditioning and then we'll move on to the phobia side of things. So let me just close this chapter 3 PowerPoint. Okay, yep, close that and I just have to share a new screen now. So chapter 5, models, yep, models to explain learning. Okay. And let's just go to the elements. So the elements of classical conditioning, the more questions you do, the easier it'll be for you to understand. So these are the elements of classical conditioning here. All our UCS, CS, all those favorite words that we have that we love to hate, I suppose. So we've got the neutral stimulus, the unconditioned stimulus, unconditioned response, conditioned stimulus, conditioned response. Okay, so remember when we were doing questions on this in class, I said that whenever you get a scenario, the neutral stimulus and the conditioned stimulus are basically going to be written the same way because they are technically the same thing. The neutral stimulus in the during conditioning phase becomes the conditioned stimulus eventually. Okay, so that's why we name them as the same thing. The unconditioned stimulus causes the unconditioned response, which is why we've grouped them together here. And obviously the conditioned stimulus causes the unconditioned response. So the unconditioned stimulus is the natural thing, the natural object or event or situation that would cause a natural response. Like in Pavlov's study, this was the food. Okay, the food is a natural thing that whichever animal you put it in front of, food will make that animal salivate. Okay, so that's obviously talking about the UCS and the UCR. Now, when we're talking about the classical conditioning process, Pavlov actually paired the food repeatedly with the bell, which was the NS. Okay, so the UCS and the NS are paired repeatedly associated and presented in front of the dog, eventually leading to the neutral stimulus kind of getting out of the picture because the neutral stimulus has now transformed into the conditioned stimulus. And now the UCR is also out of the picture because now the conditioned stimulus, which is the bell, is producing a conditioned response, which is the salivation due to the bell. Okay, so that's basically a whole lot of scribbles, but yeah, that's basically the main idea there. Okay, so just differentiating between each element now with an actual definition. So the unconditioned stimulus is any stimulus that always produces a reflexive, naturally occurring response. It's anything that produces a natural response in an organism, whether that's an animal or a human. For example, if someone was to train somebody to blink upon hearing a beep, the initial unconditioned stimulus for that study would be throwing dirt into someone's eye, because throwing dirt into someone's eye is a stimulus, it's a situation that would consistently produce a natural response of blinking. Okay, regardless of which superhuman you take from this earth or super animal you take from this earth, if you throw dirt into that animal or that human's eye, they will blink because they need to get that foreign substance out of their eye. It's a natural response. The unconditioned response in that case will be blinking due to having dirt thrown in your eye. Okay, the neutral stimulus will be the beep because no one blinks upon hearing a beep, but that's what we're trying to train the person or animal to do. So the neutral stimulus will be the beep, which will eventually become the conditioned stimulus, which is also the beep sound. The conditioned response then will eventually be the same response. It's going to be blinking due to hearing the beep. Okay, before it was blinking due to having dirt thrown in your eye. Now it's going to be blinking due to hearing a beep. So we've trained that response in that organism there. Okay, so those are the main 5 elements. So hopefully that makes some sense and you can differentiate between those. Alrighty, next topic we have is parts of the brain. So parts of the brain involved in memory. So let me just close this PowerPoint up now and share a new one. Parts of the brain involved in memory would be chapter 6. Okay, so parts of the brain involved in memory, if I can just skip all the way through. Here we go. So brain regions involved in storage of long-term memory. So we've got 4 main brain regions that are typically or generally involved in memory. The first one is the cerebral cortex, which is basically referring to the brain in general, hippocampus, amygdala, and the cerebellum. So I'll tell you guys, and I'll focus on what are the specific types of memory affected in or responsible, that are held responsible by these particular regions. So obviously the first one is cerebral cortex. So cerebral cortex is a fancy way of saying brain lobes. Not all the lobes of the brains are actually directly involved. The main lobes of the brain involved in episodic and semantic memories are your frontal and temporal lobes, with your frontal lobes actually having a big role. And a lot of people don't even understand this link. They don't understand that the frontal lobe actually does have some role in memory. If you remember last year when you did the experiment, and even this year, I think when we talked about, we did it last year. When you did that, when you studied about that guy called Phineas Gage, who had an iron rod that went through his skull because of a railroad accident, okay? His prefrontal cortex of his frontal lobe was damaged. And although he had personality issues, he also had minor memory issues as well, particularly with recalling episodic memories and general knowledge and information that he'd learned in the past. So that gives us evidence for the fact that the frontal lobe, some areas of the frontal lobe, are involved in our explicit memory, which is consisted of our episodic memories, which is past events that we've gone through, as well as our semantic memories, which is general information. Okay, obviously the temporal lobe also plays a role because the temporal lobe is home to our hippocampus. And we know that the hippocampus plays a big role in explicit memory in general, in its consolidation and in its formation. Now, when it comes to the other lobes of the brain, like the occipital lobe, we know the occipital lobe is involved with, trying to draw an eye here. We know that the occipital lobe is involved with vision. So the visual sites that you see when you're going through an experience which later becomes a memory, and when you're thinking back on that memory and visualizing that in your head, your ability to remember that it was a red car that was at the scene of the accident, or that you're the first time, I don't know, you met the love of your life, they were wearing a blue color shirt or something like that. Those visual images that are connected to your memories are stored in the occipital lobe. So obviously if you're like blind, you don't have those visual elements of memories, or you kind of impose them yourself. You don't really have them originally. Okay, when we're talking about the temporal lobe, we know the temporal lobe is above and around each of our ears, which gives you a hint as to what it should be responsible for. It's responsible for hearing. Okay, I'm not. Okay, good. I thought they were going to call the year 11s to the multipurpose hall because I'm here now. No one can come here. Okay, so I'm not going to bother drawing an ear, but you should know that temporal lobe is responsible for hearing. So all the sounds that you would remember, like if you were witnessing an accident and the sound of the car crashing into another car, or the sound of someone singing during a talent contest that you were a part of, okay, or the sound of your mum screaming when she realized a snake had slithered into the house, or something like that. Okay, all those sounds are basically stored in the temporal lobe. So when you rethink or you revisit a memory that has happened in the past, and you're trying to think about what the sounds in that memory were, your ability to remember those sounds is because they were stored in the temporal lobe. And in the same way, people who are deaf or who have a major hearing impairment would not be able to kind of recall the sounds of their memory in the same way as people with healthy hearing would. Okay, so in a nutshell, your frontal lobe has a big role in your episodic and semantic memory along with the hippocampus. Episodic and semantic memories are kind of formed in your frontal lobe and they're consolidated by your hippocampus, which is in the temporal lobe. Anything to do with the visions and the sounds in a specific memory that you have are stored in your temporal lobe as well as your occipital lobe, depending on whether it's a sound or a vision that we're talking about. Okay, so that's the first region of the brain involved in memory, and that's basically how it's involved. So this is just a diagram of the temporal lobe, just to show you where the hippocampus and amygdala, sorry, are housed in the brain. Okay, they're housed in the temporal lobe. Now, you're not going to be asked to label this kind of a diagram, but it's just there to give you a general idea. The hippocampus, we know, has a big role in memory. It's involved in formation of memories like episodic and semantic memories, but it's also involved in consolidation. It plays a big role in consolidating your memories, even though when we're talking about consolidation of emotionally arousing experiences like fear-based experiences, Even though we're talking about things like, even though we're talking about the fact that the amygdala plays a big role in doing that, we're actually also looking at the hippocampus. The hippocampus is the one that does the final job. It's the one that does the final work of consolidating that experience. Hippocampus also plays a role in spatial memory, and it also plays a role in long-term potentiation. So obviously it's because of your hippocampus that you are able to learn information in the proper way, and that you are able to, hold on, I've got a crowd coming here. Just give me 1 second. I'm just going to see what's going on. Just give me 1 second. I'm just going to mute. Okay, I'm back. There was a mistake in classroom. Okay, anyway. So yeah, that's what I was saying. So basically that the hippocampus plays a pretty big role in learning as well as memory. And it's because of your hippocampus that you are able to show long-term potentiation. And eventually when it comes to reading your notes, you're able to go from just reading your notes to eventually memorizing them. And the hippocampus does play a big role in that storage of semantic information. Okay, and then we're looking at the amygdala. Now the amygdala plays a pretty big role in emotional memory. So obviously emotional memory means linking emotions. So the first time you rode your bike and you were chased by a dog and how fast you had to pedal away to get away from the dog, that's a pretty scary memory. So obviously the amygdala would have a big role in infusing your emotions related to that memory before it's consolidated by the hippocampus. The amygdala also plays a role in classical conditioning, which means that responses that are classically conditioned can only be classically conditioned because you've got an amygdala. And remember, a lot of the time when we're classically conditioning a response, we're associating fear to that response, or we're associating some kind of an anxiety to that response. Okay, a lot of classically conditioned responses actually are related to phobias, and we know phobias are developed through classical conditioning. If you don't have an amygdala in your head, no one can classically condition you to do anything. And on top of that, you can't even have a phobia because amygdala is the fear center in the brain. So if you have a phobia of bees, for example, and your amygdala has been removed from your brain, you might see a bee, your brain might know that you should be scared of the bee, but you actually won't show fear. So that's what the amygdala's role is. And the last one is the cerebellum. So the cerebellum is basically looking at motor learning, looking at memory for motor movements, looking at any kind of procedural memory that requires movement, like playing the piano, playing a musical instrument, riding a bike, all of these things, the movement related steps in those procedural memories happen as a result of your cerebellum. Without your cerebellum, you can't engage in the movements that are required for those particular memories. Okay, we've also got another topic, which is explicit and implicit memory. So I think that should be coming up somewhere here. Oh, here we go. Oh, yeah. So just before we move on to anterograde amnesia, we'll just look at explicit and implicit memory. So obviously our long-term memory is a vast, okay, when you talk about your long-term memory, can you imagine like if every bit of information, every experience you've gone through was just thrown into a cupboard, the way that, when your room is messy, you're just throwing clothes into your cupboard because someone's coming over, want it to be a mess. Imagine if that's how our memory was. We were just throwing information into a cave of this long-term memory without organizing it in any way. It's going to obviously be difficult for us to retrieve the information we need at the right moment. In the same way that when you just throw things into your closet and everything is everywhere, it's hard for you to find what you need. So long-term memory is kind of similar to that. So obviously long-term memories consist of two main types of memory. The first one being explicit memory, which in some older exams is referred to as declarative memory. And the other type is implicit memory. So implicit memory is the opposite of explicit. Now, explicit memory is memory that can be declared. And that's another reason why it's otherwise known as declarative memory, because it's something we can declare, we can talk about it, it's easy to talk about. Implicit memory is memory that usually occurs without awareness. It's a lot harder for us to put it into words and talk about it. Okay, it might be easy for us to maybe show someone how to do it. It might be easy for someone to observe us engaging in that implicit memory. But when it comes to actually recalling that, verbally discussing it, it's a bit more difficult. Okay, so explicit and declarative memories happen with your awareness. When you're revising your notes, you're fully conscious, you're in the moment, you know, you're revising your notes, you're trying to get them into your memory. When you're at school learning basic information in primary school or secondary school for your subjects, you are listening, you're consciously trying to learn that particular memory and learn that particular information. The episodic memories also occur with awareness, because when you're going through an event, you are conscious in that event. You know that it's happening to you. You know that it's something that you can look back on. Okay, when you're experiencing, for example, you know, I can't even say year 12 graduation, maybe like year 6 graduation, because that's something you've already gone through. So year 6 graduation is something you went through. And when you were at your year 6 graduation, you probably were thinking in your head that someday I'm going to look back on this. Okay, the main reason your parents take like 1 million photos on grade 6 graduation is because they know that this is something they can look back on. So these are memories that occur with your awareness, and they're memories that are easy for you to discuss. If I ask you, okay, describe to me how your grade 6 graduation was like, you can tell me about it. You can talk to me about it. Implicit memory is a little bit more difficult. It's difficult for you to answer me if I ask you something like, can you explain to me how you first learned to ride your bike? Or can you explain to me, you know, at what particular stage of your life you learned to ride your bike? It's a little bit harder for us to discuss these ideas. In comparison though, if I ask you to show me how to ride a bike, that's easier for you to do. It's easier for you to show me a procedural memory than it is for you to explain that to me or to write about it to me. Classically conditioned memories are the same. The dogs in Pavlov's study, probably if they could talk, they wouldn't be able to explain how they were classically conditioned. But we know that they were classically conditioned and that they probably made some association between the NS and the UCS in order for the NS, which was the bell, to eventually become a conditioned stimulus. So there is some memory at work there. The dogs just don't know how to explain that, okay? And it's actually difficult that, well, when you are the victim, when you are the participant that is conditioned, it is very difficult for you to explain that at that particular moment, that this is what is happening to me. Okay, for us, it's probably easy because we already know the whole theory of classical conditioning, but it is actually in practice quite difficult to do that. Okay, so that's the main difference between explicit and implicit memory. Okay, the next topic. So I think the next topic was anterograde amnesia, and then we're moving on to specific phobias. So I'll just move on to chapter 7, which is where we covered anterograde, and then we'll look at specific phobia and that question as well. Chapter 7. Okay, cool. So just moving all the way down to anterograde amnesia. Okay, so when we're talking about anterograde amnesia is a type of loss of memory. We know what amnesia is. We've heard it everywhere. Even before you did psychology, you would have known what amnesia is about. Amnesia is the loss of memory. Anterograde amnesia is when you lose memory, but only for information or events that occur after your brain trauma or injury. So let's say you get into a car accident and you know, you suffer some brain damage there, and you've lost some information, you've lost your memory for everything that occurs after. So you can't remember the names of the doctors that are treating you in the hospital. You can't remember the name of a new person that your mother introduces to you that have come to the hospital. But you can remember things like your graduation at school, who your school friends are, information that you learned while you were in your first year of uni, all that kind of stuff is still there because those were things that were formed before the brain trauma. Okay, but amnesia, anterograde amnesia, is only going to affect you for information or things that you learn after your brain injury. So usually anterograde amnesia occurs in 2 ways. The first example, which I just mentioned, which is obviously through a head injury, like getting into a car accident, getting into a sporting injury, or through Alzheimer's disease. So we know Alzheimer's disease is a neurodegenerative condition, which means that it progressively or little by little, slowly, what it does is that it tries to kill off the neurons in your brain, kill off the neural connections and degenerate. Degenerate means to basically eventually lead to destruction or deterioration of those neural connections. Now, generally with Alzheimer's disease, that deterioration, when it starts to affect the memory centers of the brain, like the frontal lobe and the temporal lobe, that's when people with Alzheimer's disease start to actually develop anterograde amnesia as well. It doesn't happen straight away, but eventually they will develop this. Now, obviously, anterograde amnesia happens because of damage to the hippocampus and the amygdala. okay, as well as some elements of the frontal lobe. Because remember, we said the frontal lobe does have a role in explicit memories like episodic and semantic memories. This means, what does this mean practically? It means that if you developed a head injury at the age of 15, which is obviously before you do VCE, before you do university, and you were unfortunately in a car accident and you had damage to your brain, to those areas of the brain involved in memory, that means that you're not going to be able to really progress your life further than your age of 15. You're not going to be able to finish VCE because after your injury, you're not going to be able to take in new content. You're going to forget everything. You're not going to be able to start uni because, again, you got your brain injury at 15 years old. You can't take in new semantic information. You can't store or form new episodic and semantic memories. So you've basically got only all the memories, all the information, all the memories that you've had up to the age of 15 is all you've really got in that particular example there. Okay, so basically one thing that isn't affected though in terms of anterograde amnesia is procedural memories. So obviously someone who gets a brain injury at the age of 15 and develops anterograde amnesia, just because they can't go to VC or uni, it doesn't mean that they can't learn how to ride a bike. It doesn't mean that they can't learn how to cook. It doesn't mean that they can't learn how to sew. Okay, these are still skills that they can do. In terms of comparing Alzheimer's disease and Parkinson's disease, they are both neurodegenerative conditions. That's your first similarity. They are both obviously going to lead to destruction or deterioration of neurons in the brain. The third thing, though there are differences as well. So the differences are that with Parkinson's disease, it's more to do with, we do have issues of memory loss in Parkinson's disease, but not to the extent of Alzheimer's, okay? Alzheimer's generally have more memory conditions because it directly affects those brain areas involved in memory. With Parkinson's disease, it affects movement more so than memory. Eventually, it will affect memory as well, but because the dopamine-producing neurons are the things that are affected in Parkinson's disease, it affects the motor messages and the sending of those motor messages. So we see more motor symptoms, more physically apparent in Parkinson's disease, whereas in Alzheimer's, it's more to do with our actual memory loss from the beginning or from the get-go. Okay, so that's basically kind of just comparing Alzheimer's and Parkinson's disease, and it's good to compare them and look at the similarities and differences between them. Okay, so now we can move on to our specific phobia. Let me just quickly go back to chat and see that I haven't missed any topics. Okay. Yeah, okay, so we just got to go through systematic desensitization and the question. So I'm just going to try to copy and paste this question. I don't know if it'll work. Yeah, it should be fine. Okay, let me just get that from my email because I think I did see that in my email today. Ah, yes, it's there. Okay. Okay, so. All right, so let me just copy and paste this into the chapter 13 PowerPoint. Okay, cool. And then I'll just screen share the new one, chapter 13. Okay, so let's just open this up. Cool. Okay, so when we're looking at this question here, as a child, David would become frightened when he saw his mother, Tracy, scream and run away every time she saw a cockroach. Tracy always appeared relieved when she was no longer near the cockroach. David acquired the same phobia of cockroaches and also screamed and ran away whenever he saw a cockroach. How could context-dependent cues help David remember his psychologist's breathing retraining instructions? Okay, so basically what we're looking at in this question here is it's mixing up two topics. It's mixing up the context-dependent cues and it's combining that with the breathing retraining instructions and how David is going to remember those instructions. So this question is more focusing on context-dependent cues, and we're just using breathing retraining as an example for that. So if we think about what context-dependent cues are basically any retrieval cues that are provided by the environment or the place. So when we're talking about context-dependent cues with reference to this scenario, you know, we could talk about maybe David going into a particular room, like his bedroom, or a particular place where there are a lot of cockroaches maybe, or a particular place that is easy for him to remember. So maybe the breathing, maybe his psychologist would take him to a specific park. And so that's close to his home. So the psychologist and David go to a specific park that's close by to his home that he often passes by each day. They sit in the park, and then the psychologist gives him the breathing retraining instructions, telling David, okay, David, listening up, you know, you got to breathe in slowly, you got to inhale, and then you've got to exhale. You know, you've got to make sure that you're breathing at a proper pace. You've got to make sure that you're not breathing in an irregular way, that you're not frantically hyperventilating, blah, blah, blah. Okay, so all that, while she's giving him the breathing retraining instructions, she's got to make sure that they're always in the same place when they are being given those breathing retraining instructions. So what that basically means is that every time the psychologist wants to tell David these instructions, they should go to the same park, sit in the same bench or the same area of that park, and the psychologist should run the breathing retraining session with David in that manner every day or every time they have the session. So over time, what that's going to cause David to do is David is going to start to use the park where they'd have the breathing retraining sessions as an environmental cue or a retrieval cue related to the actual physical location or place. And that's going to help him to better remember the breathing retraining instructions that he actually learned in that place. So next time David is feeling stressed or anxious, he would make a trip to that park, sit on the same bench, and it would help him to remember the actual instructions for breathing retraining. Does that make sense? And if it doesn't, just let me know in the chat box and I can explain it in another way. Okay, and while you guys kind of like think about that answer and whether it makes sense or not, I'll just read the next question. If someone is sleep deprived, are they more likely to have more NREM or REM sleep? Usually we say that if a person is sleep deprived over a period of days, or a period, like a long period of time, that they will go into something called REM rebound. Now, REM rebound is not a topic for our study design, but the answer to that question is REM sleep. If you are sleep deprived for a number of days, you will spend a longer amount of time in REM sleep because it's more of a priority for your brain to become replenished than it is for your body. Okay, so obviously, that is how it works. Obviously, it depends on your situation as well. So if you're a marathon runner who's been running marathons for a few days' time and you were anxious about the marathon, so you were sleep deprived because of that, then you'd go into NREM sleep because your body is just so much more deteriorated compared to your brain. But in general, for a general person who's not a marathon runner, who's not physically exerting themselves to an extreme level, if I miss out on, let's say, 3-4 days of sleep, when I eventually get the chance to sleep, I'm going to spend a longer amount of time in REM sleep. Okay, so I think we've got one more topic to look at, which is systematic desensitization. So systematic desensitization, where is that? That's all the way in our interventions. Yep.
We also go through REM, the stages of NREM.
Oh, yes, we were supposed to go through that. I'll just go through this one and then I'll go back to chapter 9.
Okay, thank you.
No worries. Okay, so systematic desensitization is our psychological evidence-based intervention. Again, making sure you understand that, you know, systematic desensitization is about it's a psychological-based treatment. So if you ever get a question that says, outline one psychological evidence-based intervention for addressing specific phobia, even if they don't mention the word systematic desensitization in the question, you as a student should know what they mean by psychological evidence-based intervention, because there's only two. So if Vika asks you to name any one, you're either going to talk about CBT or you're going to talk about systematic desensitization, because these are the only two psychological evidence-based interventions. So make sure you really know which one is the biological one, which one is the psychological one, which one is the social one. Because in the past years, Vika have been really kind of tricky in the sense that they like to see how well students' keywords and key terms are and how many students are actually using the study design. If you're using the study design to study, we usually use the study design in these PowerPoints as well when we name the different slides. But like, if you're using the study design to study, you would automatically know that the only two like psychological evidence-based interventions are systematic desensitization and CBT. So you would automatically be confident that you are on the right track. Okay, so make sure that you are aware of these different ways in which the topics are organized. Okay, so anyway, going on to systematic desensitization. Systematic desensitization is basically trying to deal with the person's thoughts and feelings around the phobic stimulus, which is why it is a psychological evidence-based interventional treatment. So obviously what we're doing is we're exposing the patient to similar stimuli as the original conditioned stimulus, otherwise known as the phobic stimulus. We want to gradually desensitize them. Desensitize means that gradually we want to reduce their fear to that particular phobic stimulus that they are scared of. And eventually we want to be able to show them the particular conditioned stimulus without having to without them showing the phobic fear response. That's kind of like where we want to be at the end of the day. It does take time, as we talked about when we did this topic, but that is the basic idea of systematic desensitization. If you think about the word itself, systematic means kind of step by step in a logical manner. Desensitization is when you become desensitized to something. You're exposed to something so much that it doesn't affect you anymore. And that's essentially what this whole process is about. Step by step, little by little, we're exposing the participant or the patient to little glimpses, okay, to little approximations or glimpses of the phobic stimulus that they are so scared of. And we're going to expose them to those little glimpses over a period of time to such an extent that eventually they will be desensitized to that phobic stimulus. And when you show them the phobic stimulus, whether it's a teddy bear, whether it's a dog, whether it's a bird, they just don't show that fear response anymore. Their fear response is either gone or their fear response is replaced with a response of relaxation. And the reason that it's replaced with a response of relaxation is that we often pair the fear hierarchy tasks with a relaxation technique. Okay, so looking at the actual fear hierarchy of tasks. So when we're looking at the hierarchy of tasks, we're basically talking about the fact that we take the actual phobic stimulus and we divide it into a number of tasks, okay? Little tasks that provide little, like I said, glimpses or approximations of the actual phobic stimulus. So if you have a phobia of dogs, you start with tasks that are lower on the fear hierarchy, like lower fear inducing or lower in fear level, and then you move up. And the task that's at the top is the most fear inducing task. It's the scariest, most overwhelming task for the patient to go through. Remember, a lot of you in the SAC and a lot of people generally on the exam, they talk about the fear hierarchy, but they don't talk about the role of the tasks involved. They don't give examples of the tasks in relation to the scenarios. These are the things you've got to do. Step 1, mention that the patient has to learn the relaxation technique. Step 2, mention that the patient works with the psychologist to create the fear hierarchy. Step 3, mention at least 2 or 3 examples of tasks that could be on the fear hierarchy with reference to whatever the person in the scenario has a phobia of. Step 4, you're running through each of these tasks with the patient. Obviously, if the patient gets overwhelmed at any stage, they can use the relaxation technique. Step 5 is the final test where we decide, is this person actually over their phobia? Have they successfully overcome it? And how we do that is by presenting the actual phobic stimulus, several large dogs right in front of that person, letting those dogs lick that person's face and see, do they still show a fear response or are they relatively calm? Are they relatively neutral and okay with it? If they're relatively neutral and okay with it, then systematic desensitization has been successful. Again, it's easier said than done. And when we looked at the limitations of this technique or this strategy, we mentioned that it's easy to talk about on paper or on a PowerPoint, but it's a lot harder for us to do this practically, particularly because a lot of phobias have traumatic underpinnings where the person developed the phobia because of some kind of a traumatic experience. And traumatic experiences are never easy to just overcome very quickly. Okay, so that's systematic desensitization. I hope that clears that up. If it doesn't, then let me know in the chat box and I can go through it a little bit more. So the next topic that we have to go through is we just need to go back to where is it? Back to chapter 9. So I will just screen share chapter 9. So just give me 1 second. Where is it? I'm gonna close the ones that we don't need anymore. And I also have another question on the chat box. So I'll just answer that one as well. Oops. Okay, so chapter 9, and we were looking at, what were we looking at? Let me see. Just give me 1 second. Okay, stages of NREM. Yep, that's what it was. All right, let's open up stages of NREM. All right, so we've got, where is it? Sorry, 1 second. Okay, there we go. Cool. So when we're looking at chapter 9, okay, yeah, chapter 9. Okay, so when we're looking at the stages of NREM, if I can just skip through to that, yeah. So when we've got sleep, you know that we've got 2 types of sleep. The first one is called NREM, and the second one is called REM sleep. Okay, NREM stands for non-rapid eye movement because of the lack of electrical activity in the muscles surrounding the eye, or the lack of eye movement. In other words, rapid eye movement is when the eyes are moving rapidly and there's a high level of electrical activity in the muscles surrounding the eyes. Now, obviously, NREM sleep and REM sleep kind of repeat themselves throughout the night, so they do occur in continuous cycles. Generally, one cycle of NREM sleep is about 1.5 hours, 1 to 1.5 hours, because again, there are 4 stages of NREM. Okay, so that's why we do go through this sleep cycle 3 to 4 times per night. Okay, so looking at NREM sleep, we do spend about most of our sleep time in NREM sleep, again, because we do have 4 stages of NREM, and those 4 stages obviously take a while and they do take up a big amount of our sleep. Now, as we know from the restoration theory of sleep, NREM sleep is involved in your physical restoration. So it's relating to anything about the body, okay, restoring your body's resources, muscle cells, muscle cells, any kind of tears that you have, all that kind of stuff. So as the night goes on, generally what happens is that our NREM sleep duration starts to decrease and our REM sleep duration starts to increase. And that's why the sleep that you're experiencing just before you wake up is actually not NREM sleep, it's REM sleep, because we tend to spend the longest period of time in REM sleep as closer to the hours before we get out of bed or wake up in the morning. So stage 1 NREM, obviously for this year, you guys don't need to know anything about the brain waves. I think I did cross those out when we were talking about this before. But yeah, you don't need to know anything about the brain waves, so just kind of scribble out that bit. But you do need to know that stage 1 is more of a transitory stage. Stage 1 is a very short stage. It's not long at all. It's literally your body going from being awake to trying to get to sleep. So it's a transitory stage. It's like, you're just kind of like, getting prepared to sleep. And obviously it's really easy to wake up someone. So like if your parents have kind of like, just gone to bed, they're literally just about to close their eyes and then you go, like, oh, where's the dinner? I'm hungry. And then they wake up. That's like stage 1 NREM. Like they literally didn't even have a chance to put their head on the pillow. And it's very easy to wake up the sleeper in this stage. Okay, now hypnagogic state is a special feature of stage 1. Because we are transitioning to sleep, a lot of the time people might experience like kind of like things that happen because of this disorientation. Our body's confused. Is this person still awake? Are they asleep? What's happening? We're in a transitory stage here. So some people might see bright flashing colors. The more common one is involuntary muscle spasm. So that's when you feel like, you're asleep and then your leg does that weird thing where it just like, jerks out, or just kind of like, pops out. It's that weird spasm and you can't really control it and you don't know why it happens. That's called a hypnic jerk. And these are exclusive to stage 1 NREM. Okay, again, it happens because of that disorientation or confusion that your body goes through as you're going from a period of being awake to being asleep. Now in this stage, our eyes roll slowly. Remember, our eyes are not rapidly moving at all at any stage in NREM. So that's why our eyes are rolling slowly, not rolling rapidly. Muscles are relaxing, getting ready for us to sleep. And your heart and your breathing rate are continuing to decrease. Again, preparing your body for sleep. Stage 2 NREM is, again, still not like deep sleep. It's still a light stage of sleep. But when you're in stage 2 NREM and when that's showing up on an EEG, that is where the person is said to be truly asleep. And stage 2 NREM is a little bit longer than stage 1. It lasts for about 10 to 25 minutes. It is still really easy to wake up a sleeper. So sleep spindles and K complexes are special characteristic brainwave patterns. Now, although these are related to brainwaves, I'd say you still have to know them because they're not specifically talking about beta waves or alpha waves here. We're just talking about the features of sleep. So just maybe know these keywords and know that these are connected to stage 2. Now, in stage 2, again, don't worry about the brainwave part at the bottom here. That's not important. In stage 2, our body's continuing to relax itself, continuing to decrease bodily arousal and bodily stimulation, and preparing us for sleep. Stage 3 is the beginning of our deep sleep, okay? Stage 3 and stage 4 collectively comprise our deep sleep. Stage 3 NREM is basically our body's continuing to relax itself, continuing to drop those essential bodily indicators like blood pressure, heart rate, body temperature. It is hard to wake someone up in stage 3. So if they're in stage 3 sleep, you really need to put a lot of effort into waking them up. You can't just kind of like, you know, ruffle their hair. You can't just like kind of, you know, like call their name from outside. Like they won't wake up, because obviously stage 3 NREM is a deeper stage of sleep. You're more, you've pushed yourself more into that altered state of consciousness there. Again, don't worry about the theta waves here. This is not relevant for 2020, so we don't need to know about that. And the last one is stage 4 NREM. Now, stage 4 NREM is special because it is the deepest stage of sleep. And secondly, it's important because most of your sleep phenomena, for example, sleepwalking, nightmares, okay, all that stuff are pretty much apparent in stage 4 NREM. So that's why stage 4 NREM is quite important for us to know. And as we know, REM sleep is when we've got rapid eye movement. So rapid eye movement sleep is our eyes move rapidly for short periods of time. And if you're visualizing this, it doesn't really look like someone's being possessed. If when they're in REM sleep, it's more of your eyes are kind of like moving side to side and up and down. But yeah, it's like, it's not really easy. Like if someone's in REM sleep and you just look at them, it's not as dramatic as you might think. Okay, it just probably looks like this GIF over here. So it's not really so dramatic. Anyway, so REM sleep, a lot of people think because REM sleep happens after NREM stage 4 in the sleep cycle, that REM sleep is actually a deeper stage of sleep than NREM stage 4. And that's wrong. REM sleep is actually quite light. And remember, we said that REM sleep is the stage of sleep that you're experiencing just before you wake up. And if REM sleep was such a deep stage of sleep, why would it be the stage you experience just before you wake up? That doesn't make sense. So obviously REM sleep is a light stage of sleep, and it is easy to wake up someone in REM sleep. Important thing to remember, vivid dreaming, which is the dreams that you experience just before you wake up most of the time, dreams that feel so real, dreams that you can easily talk to or make a story out of as soon as you wake up. Those are dreams, and those occur in REM sleep. Nightmares are different. Nightmares occur in stage 4 NREM, so just be careful with that. And the last thing, which was also a question in the SAC, was about paradoxical sleep. So paradoxical sleep is this idea that REM sleep is a paradox, okay? Because the person looks like a dead log on the outside. They're completely still. They're not moving. They're frozen. But on the inside, there's a lot of internal activity happening, okay? So that's basically why REM sleep is also known as paradoxical sleep. All right, so those are basically the stages of NREM and REM. So hopefully that makes sense. If it didn't make sense, just let me know in the chat box and I'll explain it again. And we have another question. So I got a question in practice exam regarding difference between neural transmission and neural communication between neurons. Okay, so when we're talking about neural communication between neurons, you're focusing more on the basically you're focusing more on the LTP side of things. So the strengthening of synaptic connections, the neurons kind of like, you know, connecting together again in the future, you know, the pre and post synaptic neurons being more likely to fire together again in the future. Neural transmission is the simple idea of one neuron sending information to another neuron, and it's not really focusing on it's not really connected much to LTP. But that's a weird question. I mean, that's not a question you'd really get in a VCAR exam. I don't know which exam that was from. If you could let me know, maybe. Yeah, that's a odd question to have, because generally when we're talking about neural transmission and neural communication, they are technically the same thing, even for the purposes of a definition or a distinguished kind of question. They're basically the same thing. I mean, maybe like at a higher level, like university, if you really go into the itty-gritty parts of it, you might be able to distinguish between those two, but at VCE level, we would consider them to be the same thing. So if you found that confusing, don't stress. That's a weird question to begin with. Okay. 2020 Triumph exam. That's odd. Well, I'm not sure why they have that in, but I'll have a look at that anyway. And yeah, I'll email you if there's anything extra, but generally they are the same thing. Like I said, at the end of the day, they're not very different. Yeah, that's a odd question. Transmission is more of like you could talk about neural transmission with reference to like lock and key process and bring in the role of like, you know, the neurotransmitters more so, whereas neural communication is more linked to LTP. But they're such connected concepts anyway. I mean, you can't have neural communication without neural transmission anyway, so it doesn't make sense. Obviously, you could say that successful neurotransmission can't occur without the lock and key process, whereas neurons can still communicate. I don't know. It's an odd question. So let me see. Where's neurotransmission? Oh, okay, so this is the question. In regards to neural transmission, differentiate between neural communication within a neuron and neural communication between neurons. Okay, so here what you're going to be discussing is you're basically going to be talking about the role of neurotransmitters and the role of the lock and key process when it comes to neural communication between two neurons. Neural communication within a neuron doesn't really require a neurotransmitter to take place. It's more so to do with the, you know, the LTP side of things. So talking about the fact that if I'm a single neuron and another neuron has connected with me before in the future, it's going to be more likely to connect with me again. Whereas neural communication between two neurons that haven't connected before will be more related to the lock and key process and establishing that initial connection first. I'll look at that question and I'll send you a properly worded response for that. But yeah, that's basically what you would talk about. Okay, and obviously in questions, guys, when it says you may use a label diagram to support your explanation, it doesn't mean you have to, okay? And this was the case in the 2018, I think, Psych exam when they asked you about the lock and key process and you may use a label diagram. That doesn't mean you have to, okay? The key word is may, so you may use one if you want to, if you're one of those people that feel like you can explain things better by drawing a diagram first. It doesn't mean that you have to, okay? So you won't lose marks if you don't. Okay, next question. For neurotransmission, can we relate myelin sheath? So you want me to explain myelin sheath, the role of myelin sheath and the role of GABA and glutamate? Is that what you are asking? So basically the role of the myelin, so without opening the PowerPoint, I can just discuss it. Oh, no, can we talk about that in a question? Oh, in this particular question? Yes, you can. So when you're talking about obviously the role of neural communication between two neurons, you can talk about the fact that if one neuron has a receptor site that matches the shape of the neurotransmitter glutamate, then that neurotransmitter and that receptor site are going to lock into each other and there's going to be a click and there's going to be a good fit there. And that's going to allow glutamate to make excitatory changes on the postsynaptic neuron, on that receptor site that it's connected into. So yeah, you can talk about it. The role of myelin, you can also talk about, because obviously myelin does increase the speed of the transmission of the neural impulse along the axon. So yeah, it would be connected. You could bring these into a question like that. Yeah. Yeah. Alrighty. What other questions do you guys have, or do you have any other topics you want me to go through a little bit more? Okay, so for 2019 exam, the VCAR 2019 exam, I have posted a kind of like slide by slide or kind of like a question by question, not PowerPoint, it's a PDF. You can access that. I've actually posted on the social stream. And that will basically help you to understand how VCAR marked the 2019 exam last year, which was probably one of those exams where the multiple choice section was more confusing than the short answer. We'll try to go through that next week. I really want to probably focus on next week more on the extended response questions, which are the 10-mark questions. I want to give you guys some ideas of how to do those, of how to approach those, and eventually give you some sample answers for questions like that. So probably before next Wednesday, I'll post an extended response question on the school box, and I want you guys to try that yourself. Give yourself about maybe 20 minutes to give that one a go, and then bring that on Wednesday on Wednesday, and we'll go through that as a class, like have a Zoom about it. Okay, so that's basically just about it. Continue doing those trial exams that I've posted on the school box, on the drive. There's some really good ones in there as well. To try to do the ACID ones are normally good. The Triumph one is good. This is just I was initially confused, but now I realize this question is actually okay. It's not irrelevant after all. Yeah, so the Triumph one is good. There's also an Insight one, which I think we just got. So I will actually move that into the drive as well today. I'll do that now. Yeah, that's about it. So just continue doing those trial exams and continue sending them through. I do have a big pile, but I will eventually get them marked and give them to you ASAP. Okay, so does anyone have any other questions? No? No? Okay. Okay,
Yeah.
cool. Okay, awesome. So I am recording this session, so I will just post this as I normally do on the YouTube and give you guys the link on Schoolbox. But yeah, that's it for today. So if you guys don't have any other questions, good luck. Always email me if you have any questions, and I'll see you guys next Wednesday. Do any of you want to have a Zoom session tomorrow, last period? Like if you want, I can set one up. Just email me if you want to have one.
Yeah, I think that would be good.
Yeah, okay. I'll post a Zoom link for tomorrow for last period, obviously, because we normally have Psych anyway on Friday last period. So yeah, if you guys want to just like clarify any other doubts you have, yeah, it's just optional again. So I'm not going to have any agenda for tomorrow. You just bring your questions and I can help you out.
Okay.
No worries. Okay, guys, bye. Enjoy the rest of your day.
Bye, Miss. Thank you.
Bye. No worries.
Bye, Miss.
Bye.